Hey guys, today we're going to talk about analyzing a polynomial from its equation. So we looked at already about analyzing the polynomial if we have the graph, if we have the picture, and we found all of these things, except for factors is going to be new because we couldn't necessarily tell the factors directly from the graph, even though we could have extrapolated it. But we're going to look for factors today. We're going to look for zeros today. We're going to look for the x-intercepts today. Again, no graph. We're going to look for the y-intercept. We're going to look at the end behavior as x goes to infinity. As x gets really big, what happens? As x gets really big negative, what happens? Where are the intervals that this graph is positive, and where are the intervals that this graph is negative? And again, we're going to do all of this without the picture of the graph. But the first thing is, before we even start, I have two examples for you guys today. Before we even start, it's going to be valuable to see kind of in general, and I know we've talked about this before, but it's oh so important. In general, what are the shapes of each of these kind of forms of polynomials? So what can we have? We can have the leading power be odd and the leading coefficient be negative, or we can have the leading coefficient be positive and the leading power odd, or we could have the leading coefficient be negative and the leading power be an even power and a positive even. So this means the leading coefficient of the polynomial is negative and the largest power is odd. Think x to the fifth, x to the seventh, x to the ninth, an odd power. Same thing, positive leading coefficient, but still odd power. Negative leading coefficient, but an even power. Think 2, 4, 6, 8, 10, 12, whatever. They all do the same thing. And a positive even. Okay, so positive coefficient. So what these guys do, so a negative odd. So first off, odds take like this kind of shape or this kind of shape. Think like disco dude. So a negative odd is going to come from above, and it might wiggle here in the middle, but it's going to take that general shape. A positive odd is going to do the opposite. Okay, and there might be some wiggles in here, depending on the power, depending on the polynomial, but in general, that's the general shape. A negative even is a frowny face, and a positive even is a happy face. Okay, so these general shapes are important, especially when we go in to try to figure out the end behavior here. Also, the intervals that we're going to be positive and negative as well. Okay, so let's keep these in mind. So these are our general shapes that we're dealing with. So with this in mind, let's look at two examples now of how to find all this stuff if we have the equation and no picture. So I'm going to take these pictures down. Okay, our first example is, what do we have? Negative 2x cubed plus 18x. So our first example is negative 2x cubed plus 18x. Okay, I want to figure out all this stuff for this particular polynomial. Well, number one on my list is its factors. So what do I have to do? I have to factor it. Okay, greatest common factor, they both share an x, and I'm also going to take out the negative 2. So if I take out negative 2x, I would be left with x squared and a minus 9. Okay, oh look, a difference of squares. This can be factored further. So negative 2x, this will be x plus 3, x minus 3. Okay, so boom, factors done. Negative 2x times x plus 3, x minus 3. All right, factors are done. So next is, okay, where are my zeros? Well, the zeros are, what could I plug into x to make this whole thing equal 0? So for zeros, I want to now know, so I set it equal to 0, and I say, what does x have to equal? So, well, if that guy is 0, if this guy is 0, and if this guy is 0, then we'll all be 0, right? Because 0 times anything is 0. So if that guy's 0, the whole thing is 0. If that guy's 0, the whole thing is 0. Same thing, if this thing is 0, everything is 0 as well. So it just suffices to set all of your factors equal to 0 and solve. This is the only thing that we know how to do right now. In the future, we'll have something different for this, but right now this is what we know how to do. So what do divide both sides by -2? X would equal 0. So zeros are going to be at x equals 0. Subtract 3 on both sides. They'll be at -3. And add 3 on both sides. They'll be at 3. Okay, so those are my zeros. Next thing with my zeros, I can now find x-intercepts, because the x-intercept is just the zeros, okay, in the x place. So my zeros and my x-intercepts are essentially the exact same thing, and this is what I mean by this. So my x-intercepts will be at 0, 0 for this guy. They will be at -3, 0, and they will be at 3, 0. Notice I have 3 zeros, and I have to the 3rd power. This is also a pattern. Okay, it doesn't happen all the time, but at most we can have as many zeros as our leading power, and that's called the fundamental rule of algebra. So y-intercept in this case, plug in a 0 for x. This is kind of old news for us, but plug in a 0 for x, this whole thing will be 0, so my y-intercept will be at 0, 0. So my x-intercept and y-intercept look like are the same. Now, let's transition into end behavior. So I'm still looking at this guy, so let me think about the shape here, or let me think about as x gets really, really, really big, what is happening? Okay, if you let x be really, really, really big, what's going to happen? Okay, so you can think about it that way. Or we think, okay, this is an odd power negative. So this is a negative odd. Okay, what's the shape of negative odds? Well, they go like this. So this is a negative odd. So as x goes to infinity, what we're looking at is like, okay, if we read this graph from left to right, where's the graph go? Oh, it's going down. So this is going to go to -infinity. So f of x goes to -infinity. Now, as x goes to -infinity, we're going to do the opposite. So now I don't care about coming from the right, I care about going to the left. Or if you think about it from the function, as x gets really, really big negatives, if I plug in really, really big negatives, where's this thing going? Or think about as x goes to -infinity, means we're looking at this thing from the left. Well, from the left, it looks like it's going up. So therefore, as x goes to -infinity, the function is going to infinity. So f of x is going to infinity. Okay, the interval where f of x is positive. So I'm going to draw another rough sketch of this graph. Not just the shape, but also involving these x-intercepts. So let me draw a graph. Our x-intercepts are at 0, 0. They're at -3, 0. And they're at 3, 0. So this is 3, 0. This is 0, 0, and this is -3, 0, and I'm just roughly sketching this graph. So I also know, that this is a negative cubic, so I know that this thing is coming in here, and what it's going to do is it's going to bump down, up, down like this. Okay, polynomials will alternate. If they come down, what goes down has to come back up, what goes up must have to come back down, and then it kind of goes to its final destination. So this is roughly what this graph looks like, and these can be bigger or smaller or thinner. I'm not really sure about that, but I do know this is kind of the general thing that's going to happen here. And I know this because it's an odd polynomial, it's negative, and I also know that it hits here because I figured out where my x-intercepts are. So with this information, kind of with this picture in my head, I can now figure these two things out, okay? So visual representations are really helpful. So let's see, where is f of x positive? Okay, well, it's positive up here. So f of x positive, again, just means where does it exist above the x-axis? Where is the thing positive? Well, it's positive whenever it's up here. So when is it up here? Well, it's up here coming in from -infinity. And it stays positive until it hits its intercept. Okay, and then it goes negative, and then it comes positive again at 0. So union, the interval from 0, we're positive from 0 all the way to 3. 0 to 3. And then it looks like we're negative again, so no more positive. Okay, so the opposite of this is where is f of x negative? Okay, well, f of x is negative just means where does this graph exist now below the x-axis? Okay, well, below the x-axis, from here to here, and then from here onward. Okay, so between here and here is from negative 3 to 0. So from negative 3 to 0, and again, I'm just looking at the x-intercepts. So from here to here, we're negative, and then from here to infinity, we're also negative. So that would be from 3 to infinity. From 3 to infinity, we're also negative. And there we go. So I did end up drawing a picture, but I could only draw the picture after I figured out my factors, my zeros, and my x-intercepts. I also needed to know the generalized shape of this polynomial, which is why knowing those shapes and knowing like the directions are so important here. Also, the other fact that we used is we used that kind of the what goes up must go down, or what goes down must go up, right? If these are the intercepts, well, how are they going to cross through those intercepts besides passing down, up, down through them? Okay, we can't draw a straight line through them because we have a different amount of intercepts. We can't and polynomials are smooth.